Alright, this is example 1 in module 4. As usual, I'm going to assume that you've already worked this problem, so it doesn't require any setup. Alright, so the first thing that we need to do is determine what the effective capacitance of these 5 capacitors connected to the EMF is. And we're going to use a combination of the parallel and series capacitance addition rules. So in parallel, the capacitance, or the effective capacitance, or the total capacitance of capacitors that are connected in parallel is just the sum of all of the capacitances that are connected in parallel. So C total is equal to C1 plus C2 plus C3 plus however many more capacitances we have. In series, it's the inverses that add. So 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus, again, however many capacitances we have in series. So, to determine what the effective capacitance of all 5 of these capacitors are, we have to identify capacitors that are in series or parallel and then replace them with their effective capacitance. So, for example, C4 and C5 are not connected in parallel or series. They're not connected in parallel because the right sides and left sides of those two capacitors are not connected directly together. They're not connected in series because the capacitors aren't connected directly together. There's a junction here in between. And in order to be connected in series, there can't be any junctions that connect to other capacitors in the circuit. So those two are not in parallel or series. C1 and C4 are also not connected in parallel or series. So we can't use the parallel series addition rules on those yet. But if I look at C2 and C3, those two are connected in series. They're connected directly together. There's no junction in between them. So I can replace these two capacitors with a single effective capacitor using the addition rule for capacitors in series. So let me redraw the circuit with an effective capacitor that replaces C2 and C3. So here's my EMF. Here's C4. Here's C5. Here's the effective capacitor that's going to replace C2 and C3. And then I have C1 up here. So 4, 5, 2 and 3 together, and 1. Now I need to determine what the effective capacitance of this capacitor C23 is. And that is going to be the sum of the inverses. Well, I guess the effective capacitance will be 1 over the effective capacitance is going to be 1 over C2 plus C3. That means that the effective capacitance is going to be the inverse of that. I have values for the all of the capacitors in the circuit, so this is going to be 1 over 2 microfarad plus 1 over 3 microfarad, 1 over all of that. And I get 1.2 microfarad. Now if I need to again try to identify capacitors that are in parallel or series. The only two capacitors that are in parallel or series now would be this effective capacitance that I just created, so the effective capacitor for C2 and C3, and capacitor 5. Those two are in parallel, so I can replace them with a single effective capacitor. And the effective capacitance is just the sum of the two capacitances. So I'm going to redraw a circuit that contains those connected in, or those two capacitors replaced by a single effective capacitor. Here's capacitor 1, capacitor 4, capacitor that represents 2, 3, and 5, and my EMF. So this will be 2, 3, and 5 now. This is 1, this is 4. So the capacitance of the effective capacitor 2, 3, and 5 is just the sum of the two capacitors that make that up, One of those capacitors is already an effective capacitor. So that's going to be 6.2 microfarad. Now, if I look at my circuit, I've got capacitor 4 is in series with the capacitor 235, so I can replace those with an effective capacitor. Capacitor 1, this is 2, 3, 4, 5. The capacitor 4 is in series with that effective capacitor 235, so it's going to be the inverses that add. Let's see here. 235 is 6.2. This is 4 microfarad plus 1 over. I get 2.43 microfarad. And now I'm down to the last two capacitors. Those two are in those two are in parallel with each other, so I can combine those two. They're in parallel, so the effective capacitance is just going to be the sum. So I get that the effective capacitance is 3.43 microfarad. So that's the answer to part 1.